Um, I'm going to start off with a question. So, how many of you think that we're going to talk about multi-threading today? No one? Two, three? I'm really sorry. I found out yesterday that the abstract that they put on the website was from a talk that I gave last year. So I only corrected it yesterday. The talk is actually more about telemetry, multiplayer, those sort of things. So if you want, you can look at the presentation in the GDC fold. I gave it in the GDC Europe last year. This thing is going to be about launching and supporting Killzone Shadowfall. I'm going to start out with a small introduction. So for those who don't know, Killzone Shadowfall is a first-person shooter. We have 24-player team-based gameplay. And one of the important changes that we made over Killzone 3 was that we introduced a game modes that users can create themselves. Well, that was a nice idea, but it worked a little bit less well in practice, as I'll show you later. Another important feature was that it was a PlayStation 4 launch title, and that meant that we had to change quite a bit of things in our thinking. So this talk is going to be split into two parts. First, I'm going to talk about what we did before launch, how we ensured that the launch was going to be successful from a technical standpoint of view. And then I'm going to move on to what we did after launch to improve the behavior of the game and to make sure that people could play in a proper way. So I'm going to start with how we did previous titles. So for Killzone 3, we were in a nice position where the PlayStation 3 had been launched for a long time, so we could hold a proper public beta. And what we used to do is we would have 3 stages of public beta. So we would start out with having a very small closed beta with about 100 players within Sony. So it was QA and other Sony studios that would join in. And then when we were happy with the stability of all the servers, we would move on to a semi-public beta. We would send about 15,000 invitations through PSN, and we got about a couple of thousand concurrent players in total. And then finally, when we were happy with the stability of that, we would move on to our final stage, which was a full public beta. Everybody can download the game and everybody can play. And we reached about 25,000 players before the servers fell over, and we had to go back to the drawing board to fix it. Well, Shadowfall was a PS4 launch title, so we didn't have that luxury. We had very limited hardware at the time. We had about 100 dev kits available. So we had to come up with something else to test our game and to ensure that when it's launched it was actually successful. So we decided early on in the development process that we were going to focus on a number of different areas, and I'm going to cover each of these areas individually. So first of all, we were going to focus a lot on telemetry, so gathering data from the game server and from the game clients to figure out if the game is performing well or not. We focused a lot on load testing. We focused a lot on real-time monitoring, making sure that we could introspect our servers and figure out what was going wrong. And the final area is kill switches, turning off specific areas in the game server. And I'm going to start out with telemetry. So the telemetry system that we have is pretty basic. We have both the PlayStation 4 client and our game servers post to a telemetry event collector, which is basically a server that caches the information for a while and then processes it and puts it in a Redshift database, which is an Amazon product and which is really suitable for analytics gathering. And then we use Tableau to visualize the data, and I'm very, very positive about Tableau as it's a really powerful tool to quickly investigate your data. And I'm going to show you some things that we did before we launched to look at our game in various ways. So this is a multiplayer map, actually. And what we would do is every Friday in the company we would have play tests. Everybody in the company could play, and the game would send telemetry data. And this is a top-down view of the map where there's dots, regular dots indicating the average frame rate. And you can see we target 60 frames a second, so blue is 60, and anything below 60 is not good. So you can see here there are 1, 2 areas that are kind of red, so they don't quite get the frame rate that we want. So this would be for us a key to start looking into specific areas of the level, start making profiles there, and to figure out what's going wrong in that area. For single player, you can do kind of similar things. For single player in a shooter, the most important thing is the amount of times that you die in a level. And what you want is you want it to be quite even across all levels. And you can see here that we have the levels and we have the amount of times that players on average died. This kind of information we would collect by using external playtests, hiring in an external company and getting people to play the game who've never played the game before. And the thing that you notice from this particular graph is that, well, level 1 is kind of a tutorial level, so you don't die a lot there. But then level 2 has a very high spike, so it's 11 times that people died on average in that level. And then we go on to level 3 and it's low again, and it goes up a little bit with progression in levels. And this is a clear sign of a problem. This would usually mean that players quit after playing level 2, and you will not get those players back. So this is something that we then further need to investigate by, for example, looking at a heat map like we did with the frame rate and showing where people died and figuring out what potential problem that area has. For multiplayer, you can do similar kind of things. So again, this data can be gathered using playtests. This is a death heat map. So what it shows you is in the blue areas, when people die, they are of the Helghast faction, and in the red areas, when people die, they are of the VSA. Sorry, it's the other way around. Blue is VSA, red is the Helghast dying exclusively at those positions, and in gray areas, it's like 50-50. So half of the Helghast, half of the VSA team die there. So the Helghast team, they spawn here, and you can see when they move out of their spawn base, most of the dots are blue, so it means if people die there, it's of the opposite team, so that's good. You want to be able to move outside of your spawn base. And on the other side, we have the VSA team, and when they come out, it's red, so that means that most of the opposite team are dying there. You can see nice behavior around all the cover areas. You can see blue. So if you're coming from the blue side, you're most likely to die on the wrong side of cover. And for the other side, it's the same. But what can we get from this kind of information? Well, there's a very clear problem in a couple of areas here. You can see there's a number of red dots here, here, and here. And that is where the Helghast coming out of their spawn base are being spawn camped by the opposite team. And there turns out to be a little spot around here where you can sit and where you can snipe the entrance of the spawn base. So this is something that we would go in and look at and figure out how to fix that particular problem. Same thing you can do with the objectives. You can see that these objectives are nicely gray, so they're a contested area. But in this area, objective A, it's a little bit more red than blue, which means that the blue team has an advantage there. So it's also areas that you can then start to investigate. So the second thing that we were looking at is load testing. So what kind of things did we load test? We spent, I think, the better part of a man-year on load testing for Killzone Shadowfall. And we load tested mainly the matchmaking functionality, which I think is the most important thing of a multiplayer game. And we went quite far with it, I think. We went as far as simulating things like day and night cycles. So at the end of the day, people go to bed and games, they slowly empty up. And something that's really bad in a multiplayer game is if you enter a half-empty game. So we introduced with Shadowfall a mode to merge games together. And that was obviously something that we would need to test in a load test environment. Another thing that we test is things like featuring a game mode. So users can create their own game mode, and moderators can feature those game modes. And when a game mode gets featured, that means that the load suddenly shifts from one server to another server, and maybe a popular game mode is hosted on the same server as the newly featured game mode. So that would mean that we would have to migrate that particular game mode to a different server, and that's something that we would need to verify in the load test. Other areas that we covered: score posting, leaderboards. Those are usually things that are heavy. Next to functionality testing, we also did a lot of failure testing. So the most common thing to test for is the loss of a server, of a single server. But a worse case is actually a temporary loss of a server. So if you pull the network cable and then wait for a while and plug it back in, what usually happens is that server goes out of sync with the other servers, and things start to behave very weirdly. Another area that we covered is the outage of external servers. So the PlayStation Network, for example, we found that it was quite unstable while we were developing the game, and we were very afraid that it would take down our server set if they had high response times, for example. So we would test for that scenarios. And the final thing that we tested for is zero downtime deployment, what we have. So what we do when we update our servers, we first turn on a new server set, completely separate from the old server set, and then we flick the switch, everybody moves on to the new server set, and then we can decommission the old server set after a while. Obviously that's going to give a huge load on the first server, on the new server, so that's typically something that you need to test in your load test environment. So how does our load testing framework look like? Very early on, I think this is a quite classical approach. So you have a number of simulation clients running on different servers. They all hit the game server, and you would say there's a lot of packages that do this for you, and especially since our game server uses kind of web API requests. But we found that that was not really the case. For matchmaking, it was not working out really well, mainly because matchmaking, you have a lot of simulations clients sharing the same state. They need to know from each other that they're in the same game, and they need to coordinate that together. So we needed a connection between the different simulation clients, and that's why we couldn't use the standard load testing frameworks. Another thing that we encountered is that PlayStation Network is not really suitable for load testing because you cannot get authentication tickets from anything but the PlayStation 4s. And we were load testing on PC, of course. So we wrote a mock version of the PlayStation Network, and actually that was only like a couple of days work to implement, and gave us the possibilities to simulate failures and to simulate large delays there. And the final thing that is different is that we connect this system to our telemetry system as well. So both the simulation clients and the game server send telemetry, and then we can verify that what the simulation is doing, that it's actually working. So the game server will, for example, in the day-night situation, will report an amount of players and which games those players are in. The simulation clients will report the same information, and we can overlap them, and we can actually verify that what the clients see and what the server thinks is happening is actually the same. Moving on to monitoring. So our telemetry system is not real time. It takes a couple of hours before the data is there. And we have a lot of real-time monitoring to validate that our servers are still working. So the most important thing that we monitor is player count. You usually see a drop in amount of players as a very first sign of trouble, even if it's a small drop. We monitor things like the REST API timings and errors. We monitor our database, how much throughput we're using, the amount of errors that it's returning. We We monitor connectivity between our own servers to make sure that they're still up and running. And importantly, we also monitor connectivity between external servers, and PlayStation Network being a very important thing because, well, in our experience, it goes down about every other week or so. And then finally, we monitor low-level OS things like disk, CPU, memory, network, and we monitor backups. So we make sure that our daily backups that they work and that they're usable. On Killzone 3, we had an external team responsible for on-call support. So they would be available 24/7 to look at these kind of information and reboot servers or do things when necessary. For Shadowfall, we decided to actually do this ourselves. And I think that worked out very, very nicely. We rotate a phone among the developers, and I think there's nothing like getting called out of bed at 4 a.m. in the night to make sure that things get fixed the next day. And that's, I have to say, that worked really well in terms of stability of the server. And the final pre-launch area that we focused on was kill switches. Since we couldn't do a proper public beta, we had to ensure that we could turn off certain functionality in our game server to make sure that, that the server could continue running if there were large problem areas. Killzone.com, our website, we have a public API, we have the PlayStation Live tiles, they all connect to the same game server. If one of them turns out to be a bigger load than we anticipated, we can actually block those applications, and that would mean that we would lose the website, for example, but then at least the gameplay can continue. Another area, REST APIs are all our APIs, like score posting. We can turn them off individually. And during QA, we actually tested that we could turn off these APIs without impacting the game too much. So in case of score posting, for example, if we kill the score posting API, then obviously no one is going to be able to post scores anymore. But the game has been programmed in such a way that in that case it falls back to storing all those stats on the hard drive. And it will post the stats later on. So you won't get your unlocks straight away, but the next day or maybe the week after when we fix the server, then you can still post your scores and nothing is lost. Another area that we made kill switches for is all the things that we couldn't really test in our QA environment. So we had about 30 QA in total that we could use. So things like game merging that I talked about before, so merging the games at the end of the day when they're half empty, there's no way to properly test that in QA. We could only test it in a load test, but obviously we could measure that it worked, but we couldn't really verify that it worked. So we made kill switches for those kind of behaviors. And the final area is that we could block some internal systems like telemetry to ensure that if the bandwidth was too high, that we could kill it. So then we launched our game, and it was actually quite successful. We didn't have any downtime actually, surprisingly, so then we started looking at how is our game behaving. And the most important area that I think for a multiplayer game is the matchmaking system. There's always a lot of complaints about matchmaking in forums, so we really started focusing on that. And I want to cover what I think are the most important areas for matchmaking, and I'm going to use telemetry data to analyze it and to show you what we did to improve the behavior there. So there's a number of areas that I'm going to cover. So first of all, latency, how long it takes before you can see someone die when you shoot him. Full games is something that people are very interested about. Having a balanced game, both in player count and in skill level. Having a choice of game modes, which is what we provided by making the custom game mode option. And the final area I want to cover is to not have any dropped connections, to not get kicked out of the game. And I'm going to start with low ping first. So this is a table that I made from all the different servers that we host around the world. And what it measures is You have a player in a particular region, and so these are all the server regions, and we call a player from region Tokyo when the lowest ping is to the Tokyo server. So it doesn't actually mean that this player is in Tokyo, but it means that he's closest to Tokyo. And what you should notice from this table is that the diagonal obviously is playing in your own region. And I made everything red that is below 100 millisecond, and I think 100 millisecond is kind of an acceptable ping to have. And you can see up to about here is 100, and then it's higher. Everything outside your own region, with one exception, means you're above 100 millisecond ping, which means that you have a kind of a bad latency. The very first and most important thing is to try to avoid any cross-region play for your players. And that's a very difficult thing to get right, because there are small regions. For example, Asia is a very small region for us, and there's just not a lot of players in that region. So we have trouble filling the games there. Another thing that we wanted to enable is for friends in different countries to be able to play with each other. So we don't completely disallow cross-region, but we try to discourage it, and there's a big penalty in our matchmaking system to try to avoid it. And we actually achieve a 98% success rate of people joining in their own region in the largest regions, and about 80% in the smallest region, which I think is quite okay. And the main thing we did there to achieve that is to tweak the waiting time for players in small regions to make sure that they wait long enough for other players to become available. And also we have a system that merges back games into their own region. If we have enough players spread around the world in various regions, and let's say they come from Asia, but there weren't enough people in Asia at the moment, and they ended up in some other country, they will, after the game finishes, they will merge back to their own region, and then we'll fill a full game again. Another thing that I want to mention is ping cable versus wireless. This is something that not many people realize, but it's actually quite a big issue. So about 43% of our players play on wired connections, 57% of our players play on wireless connections. And if you look at these graphs, so this is ping, and this is how often we measured that ping. So we send ping information every 30 seconds or so from all the players across the world. And you see these two graphs are shifted by about 15 milliseconds. So by just connecting your PlayStation with a cable instead of using Wi-Fi, you gain 15 milliseconds already, which I think is quite a lot. And another area is the amount of dropped connections. So it's about 50-50, but only 20% of the dropped connections come from wired players, and 74% of the dropped connections come from players on Wi-Fi. So I think in general, playing a multiplayer game on a Wi-Fi connection is just a very bad idea. And we try to educate our players by putting message boxes into our game and having a screen where you can measure your internet connectivity, and it gives you a score, and it gives you a lower score if you're on Wi-Fi. Okay, talking about various server locations around the world. So we launched in the same areas where we launched for Killzone 3. So we had servers in US East, US West, in London, Sydney, Tokyo, and in Singapore. And then we started looking at our telemetry data, and we started looking, okay, where are players and which players have a relatively high ping compared to other players. So the very first thing that we noticed is that this time around there were actually quite a lot more players in South of America. So we created a server there in Sao Paulo. And this graph shows you per country what the percentage of people is that matches into a particular region. And green means Sao Paulo, and the gray area is US West, and the pink is US East. And you can see that this actually helped for a lot of countries quite close to Brazil. with the exception of Bolivia. And also I had expected that most people from Venezuela and Colombia, they would also match into the Brazil, since they are much closer than to the US server, but that actually doesn't happen. And that has to do with the way all the packets are routed through the world. I'll show you another example. So we did the same experiment in the US, where we started out only US West and US East. And we noticed that the ping in the Central America region was quite high. So we added a new server there. And you can see that in this country it works much nicer. You can see that most people in Central actually match into the Dallas region. On the West, everybody stays on San Diego, and in the East, everybody stays in the Ashburn server region. So there we were quite happy. And then we moved to the Middle East. And the Middle East, they actually had a lot of more players than last time as well. So we wanted to help them with their ping. And it's not easy to find a location, a suitable location for a server set there. There are countries that are proud about their 100 megabit line, and that's just not going to cut it. So in the end, we settled for Istanbul. And you can see a quite surprising thing here. Only people from Turkey actually match into Istanbul. And why is that? Well, it actually turns out we started doing a lot of packet trace routes to see where packets were going. All the data from Istanbul goes to Frankfurt and then somewhere else. So if you live in Greece and you play versus someone else in Greece, that would mean your data goes from Greece to Frankfurt to Istanbul to Frankfurt to Greece, and then you have your answer. So obviously these players are going to play on the London server because it's much closer to them. So that was a very unsurprising conclusion, or a very surprising conclusion for us. And of course we had to turn off that server, and we couldn't actually find a better location in the Middle East. So what we did in the end is we moved our servers from London to Frankfurt, so that it would be a little bit closer to the Middle East, but it doesn't help a lot actually. So conclusion from this whole thing is geographically close does definitely not mean a lower ping. And in the US, it happens in the same way. We got complaints in the forum about players saying, I live in US East and I'm playing on US West. Well, if we would do a packet trace to see how their packets were routed, they were actually routed from US East to US West, back to US East. And obviously, then it's going to be faster to play on the US West servers than it is to play on the US East servers. And this is very hard for players to understand. And yeah, you really can't explain it to them. For Killzone 3, we actually offered region selection as a menu screen. You could override the region. And we don't do that for Shadowfall anymore, because it turned out that there were a lot of people who thought they had better connectivity in another region, and they would actually ruin the game for other people. So more specifically, we had a lot of Japanese players. They liked to play on the US servers, and there were a lot of complaints from US players because they thought these people, well, they spoke in a weird language and they were laggy. So there were a lot of complaints about that. Another thing that I want to mention, and this will be a recurring theme, is that if you have too many different server regions, then you will have too few players per region and you won't have full games. So what we had to do, for example, for the Dallas region, even though it worked really nicely for ping, after a while, like a couple of months after launch, when the player counts went lower, then the game quality was not good enough anymore when you got matched on Dallas, because we couldn't guarantee full games at every point of the day anymore. So we had to switch off that server to ensure full games again. So moving on to full games, a couple of surprising things. So this graph shows you party size. So you can join a game in Killzone with multiple people. We use the PlayStation party system for that, 1 to 8 people. And this is the amount of players you will see after you have joined the game. So if you join alone, then most of the time you will join a full game. And that's because our matchmaking system finds it really important to match people in full games. So we favor full games over half empty games. If half empty games, we let them bleed to death in favor of filling up full games. And at the end of the round, these half empty games will get merged into full games. So that means if you join a game, it's almost always full. However, if you are with 2 players, let's do this. If you're with 2 players, you can see the graph shift, and you can shift and shift and shift it further until you're with an 8-player party, and then almost always you end up 8 versus 1. Well, that's obviously not going to be a very balanced game, and that's not going to be fun at all. And we decided that we didn't want to split up parties. We find it important that players who join up in a party, they play on the same faction. So that meant that the only option was to place them in a game 8 versus 1 and hope that other people would join in. But that's, in retrospect, that maybe wasn't such a great idea. Luckily for us, I want to say more than 2 in a party is very, very, very rare. So 8-player parties, 0.00 something %. With 3 players or more, it's already like less than half a percent. But if you expect more parties in your game, then the way that we join people is definitely not the way to go. Moving on to team balancing. So we use a system that we borrowed from chess called Elo-Glico. It is a one-on-one algorithm, and what it does, if a good player plays versus a bad player, then the good player is expected to win. So if the bad player loses, he actually doesn't lose that many points, and the good player doesn't actually gain that many points. So it's kind of weighted towards what the expected end result is. Obviously, we had to adjust this to fit our multiplayer mode. So how did we do that? First of all, this is the scoreboard. So these are our players, these are their scores. And we divide the score by the time that they played. And we do that because we have late joiners. Being at the top of the list doesn't mean that you're the best player. It could mean that you have been in the game the longest. And then we discard all the players that haven't played long enough. So in this case, players that have 0 score. And then we calculate the Elo-Glico rating by simply taking all the pairs. So this is me. I won from this guy, from this guy, from this guy, and from this guy. And I lost from this guy, this guy, and this guy, and this guy. So I ran the Elo-Glico calculations 8 times in total, and that gives my final ranking. I have to note that we only take your own team into account when calculating the score. And the reasoning behind that is that if you have a very good team versus a very bad team, then you will see that all the scores on this team are higher than the scores on this team. So we take people that have been in a similar situation and compare them against each other. So this system we also had for Killzone 3, but we enhanced it a little bit. So for Killzone 3, we noticed from our telemetry data that when we used this skill calculation and we separated players in different games based on this skill calculation, we noticed that we had too many groups, and we ended up with half-empty games again. And especially there was one poor guy who managed to, trigger a bug in the Elo-Glico calculation, and he managed to end up with a rating score that was like far above 3,000, where 1,500 is normal, which meant that he was in a bucket where there was no one else, so he unfortunately couldn't play anymore. So we don't do that anymore. What we do now is we only use skill-based rating to balance the game when the player count is equal. So if a new player comes in, we put them on the team with the least amount of players. And if the amount of players is equal, then we use skill rating to find out which team to put him in. And also at the end of every round, we rebalance the games. We shuffle bad players with good players until the skill rating is equal, and then in the end we will have a balanced game. So basically you can have a skill-based, unbalanced game for one round, and then it should be fixed at the next. So another area that I want to cover is having a choice of game modes. So when we shipped Shadowfall, we had a screen that looked like this. And this allows you to pick which game mode you want to play. And you can see there's a lot of choices. And this had the same problem as all the other separation that we had in other systems. This separated the player base, and it would mean that, okay, these three, maybe you could get a good game, but anything there, if you would select it, you would not find a match. Simply because unless you're Call of Duty, you cannot have enough players to support this many game modes. So we changed this screen around, and we changed it so that it only shows a couple of options now, and we can still feature game modes. So if there's a player that makes a game mode, we can feature it, and we can get people into that game mode. But we try to limit the amount of game modes that people play, just so that they can have a better quality game. And this screen is still there. It's, you can still create your own game mode and play it if you want to, but it's mostly meant for playing with friends if you want to do some custom game mode. The final area I want to cover is dropped connections. So this is a graph of amount of errors over time. So you can see the date here, and you can see the amount of errors per hour, per player. You can see two peaks, both PlayStation Network related. Again, a word of warning, be prepared, it happens a lot. But more important for us are these red and purple lines. So these are actual socket connectivity errors. And you can see that it's quite constant, and then at a certain point it just drops. And that's because at that point, like about here, we started doing an A/B test. Half of the servers we updated to a newer version, and we tweaked a little bit with the buffer sizes to ensure that we have enough space there. And it actually meant that we could get the amount of errors that people see on average below once every 10 hours, which I think is a quite nice place to be in. And another area that I want to show you where we used telemetry is we had complaints in the forums. People said at the end of every round I get kicked out of the game. And this is the particular error, so it's the ENGT timeout, which basically means I cannot connect to the server anymore, I cannot hear back from him anymore. And luckily for us, we were tracking all the router types that people were using. And we use that using an UPnP query to figure out what the name of the router is, and we send that with our telemetry stats. And you can see there's this one modem that has this error a lot. And this one modem is very popular because it was handed out by a lot of providers, especially in the Asia region. And it's a Technicolor TG587. And what happens is that it has some problem in its firmware that if you use a socket and if you use a UDP socket and you open a connection to one IP, and then, or actually you don't open a connection, you just send packets to that IP. If you then send it to another IP, then those packets will not arrive and they will get blocked by the firewall. So what we actually had to do on round rollover, we migrate to new servers every now and then. So that would mean that these players, they got kicked out of the game when they migrated. So what we had to do to work around that is basically close the socket after every game and create a new socket and thereby work around this whole firmware issue. But without telemetry, this is something that we would have never found. And there were a number of other router issues like this that we found. So to conclude, I think we had a very successful launch. We had about 2 times downtime of both of less than an hour. That were our own mistake. We had many more smaller downtimes from PlayStation Network, but I tend to not count that to our stats. We had to use our kill switches for a couple of times, to especially for these hard-to-test areas that didn't work as well as we had expected them. And another thing I think is important is that matchmaking is really a hard problem, and without the telemetry data that we had, we would have never been able to improve it and to get it to a good quality. So that's a point I want to give you all. Implement telemetry in your game, make sure you have a proper framework where you can look at different graphs for your game, and thereby you can make your game a lot better, both technically and also what people do a lot with tweaking the gameplay. I'm mostly interested in the technical stuff. I think it really helped a lot for Shadowfall. Thank you. Questions?
Any advices from you about how to perform a load test for a really big amount of devices? Because, for example, we can have 100 devices and we can start playing on all of them and hit the server. But how to prepare for about 1 million players to hit the server at one time? And how to possibly test it even.
Yeah, so the idea is that you simulate multiple devices on one server. So that's what we do. We don't actually test on PlayStations. We test on normal machines in Amazon. And you can very easily, if you get an Amazon account, you can use thousands of servers if you want to. In our case, I think we tested up to about 100,000 concurrent. And I think we needed about 10 or 20 servers or so to achieve that.
But every server costs some.
Yes, every server costs some, but the nice thing about Amazon is that you pay per hour. So you can simply do your test, and an hour later you turn off all the servers again. So it doesn't cost you all that much. I think well, the most expensive thing was to by accident leave the servers on, because it costs about €1,000 a day. But if you just use it for an hour, then it's not that expensive. Anyone else?
You showed some telemetry data regarding dropped connections, especially comparing wired to wireless connections. Was it the UDP connection or a TCP connection to the game server?
So we have a mix of connections. We have all the gameplay data is UDP, and all like the slower traffic, like posting scores, is TCP. Most of the errors that are frequent, they are UDP based.
So this comparison was the mixed UDP and TCP.
It was mixed, yeah. But the errors that you saw, like above the zero threshold, they were all UDP related. Any other question?
Did you consider using other parameters for elo calculations? Because you used only the score from the rounds, but did you consider other parameters?
So yes, we considered other parameters, and I mean we had a lot of discussions about this, and it's all very difficult to prove if it's correct or not correct. In the end, what we chose is score because that is what players optimize themselves for. They want to achieve as high as possible score. We also considered things like using how well they played the objectives as how good they are. But it's very hard to prove or not prove that it's true. And actually, what I didn't show, but you can measure how well the scoring works. You can compare it with various other metrics that we discussed, like kill-death ratio, or how many unlocks you achieve over time. And there's actually quite a good correlation between all of those things. So I don't think it really matters that much which thing you pick.
Did you have big issues with the number of players anticipated on the launch date versus the actual number of players that connected?
No, actually we didn't, and that was mainly because the original intention was to be free to play at launch, and for the first month. So we tested for a much higher number than we actually achieved, because in the last week, I think it was decided to change it. So all the testing had been done already, and so that was very easy for the servers to manage the load.
Did you introduce router-specific fixes for connectivity issues, like check if the router is this one faulty, and then just do fix for this particular router type?
And no, we didn't make any specific fixes, but we did have to do like this workaround that I implement. But all the workarounds that we have, they are for everyone. Because not everybody has UPnP on, so we cannot always detect your router type. I think it's about 50% of the routers that we can actually detect what they are.
You mentioned about testing on the Amazon. Can you tell us something more? It was some prepared clients installed on OS and only attacking the server with data or something like this?
Yeah, so we just use Linux servers, and all our servers are Java-based, so it's just a Java application that does the attack on the server, and it's distributed. We use like a peer-to-peer network called Hazelcast to communicate between different clients, between different simulation clients. And yeah, it's all custom, so we can just we have an automated deploying process which provisions all these boxes and makes sure that they run the clients, and then they just start the test, and we can control it, say how many we want to have through a web interface. No more questions?
I have a question about matchmaking time, because I wonder how you considered the time of matchmaking. For example, when matchmaking is really long, then do you choose worse game or better game, or still try to connect to better game?
Okay, so what we do is we have a graph that says time versus minimum amount of players required to start a game, and after like 30 or 40 seconds, then the minimum is 2. So you never have to wait more than, well, I think the average waiting time is 0 seconds, but in Asia it may be like 10, 20 seconds, but I don't think there's much that goes above that.
Did you have any issues with the bandwidth of telemetry data that you needed to send to the server versus the gameplay code that needed the bandwidth?
No, actually not, because the telemetry data that we send is heavily bit compressed, and I think we use about 2 to 3 kilobytes a second for game clients, and we use 1 kilobyte per second for telemetry data maximum. So it's a fraction, and I think we're well below what I think is like 50K is about what you can expect players to have, or maybe 25 up. So we're well below that number. I don't know how much time we have.
Last question. How much of your gameplay code relies on the server-client architecture communication, and how much of your gameplay code relies on the peer-to-peer connections? Percentage.
Well, we don't have direct peer-to-peer connections between clients in the game, so the answer is 100% is server clients. Okay. Otherwise, just walk up and then I'll answer your questions.
Thank you, our speaker. So.